Alright, this is part 3 of a test on set theory and probability. In this video, we will work with the probability of a deck of cards, and we will deal with the formulas of probability. These formulas right here. And so we will solve some word problems involving those formulas, and we're going to have to work backwards. But first, the cards. Alright, you use a regular 52 card deck to find the following probabilities. You are drawing one card. What is the probability of drawing a face card or a red card? Okay, face cards are these cards over here with faces. So you can see how many of those there are. So there's 12 of those. Red cards are all of these cards, like the lower half of this whole situation. So basically, if I cover up the black cards that are not face cards, if I take these out of the equation, alright, these are the cards that we're dealing with. Alright, the red cards, red card or face card. All of these are the cards that we want. So understand that a full deck of cards is 52. So how many cards are we looking at? Well, let's see. The easiest thing to do is each suit has 13 cards in it. So there's 13 hearts and there's 13 diamonds. Okay, so far, so the red cards, I should make this a little bit bigger. Alright, so the red cards, there are 26 of those. Now, in addition to those red cards, we have 6 other face cards. We've already included some face cards, but we also want to include the black face cards. Okay, so I'll say plus 6 black face cards. Alright, that will be the total number of cards that we are dealing with. So 26 plus 6, that's going to be 32. Alright, so there are 32 cards out of a total of 52 that we are dealing with. Okay, so 32 out of 52. That's 8/13. Which is 61.54%. Okay, now moving on. You are drawing 2 cards without replacement. What is the probability of drawing a queen and a 3? So without replacement, that means we're drawing 1 card, and without putting it back, we're going to draw another card. So the probability of 2 things happening in a row like that. Here's the formula that we are working with. This one right here. Alright, the probability of the first thing and the second thing is the product of the 2 individual probabilities. Okay, so first, the probability of drawing a queen is going to be, let's see, how many queens are there? Alright, well there's 1 queen in every suit. So our probability of drawing that queen is 4 out of 52. Okay, let me just... Alright, probability of drawing a queen is 4 chances out of 52, which is going to reduce down to 1 chance out of 13. So that's probability of drawing a queen. Okay, and then we want the probability of drawing a 3. Okay, so probability of drawing a queen was 1/13, and now we're going to multiply that by the probability of drawing a 3. Now the probability of drawing a 3 at this point, remember that we drew a queen and we did not put it back. So there are 4 3s. Okay, so I'm calculating the probability of drawing this 3. So there are 4 3s, but there are not 52 cards anymore. Now there are 51 cards left. And I don't think this reduces. All right, 4 out of 51. No. Okay, so that is the probability of drawing a 3 under these circumstances where we did not put the queen back. Okay, so if I multiply these together, that'll give me the probability of drawing a queen and a 3. Okay, so let's see. 1/13 times 4/51. Okay, that's 4 over 663. Alright, so this does not seem like a very high probability. And in fact, alright, if we move that decimal point twice, that is a probability of 0.60%. Okay, so less than 1% chance. Okay. The next one. You are drawing 2 cards with replacement. So this time we're putting the first card back. What's the probability of drawing a queen and a 3 now? Well, it's still going to be the probability of drawing that queen times the probability of drawing that 3. Okay, the probability of drawing the queen has not changed. It's still going to be 1 out of 13. Okay, I mean it started out as 4 out of 52. That reduces down to 1/13. Now the probability of drawing the 3 is now also going to be 1 out of 13. All right, because this time we're putting the queen back. So this time when we go to draw the 3, there are 52 cards still. All right, so there's still 4 3s that you could choose out of a total of 52 cards because we put the queen back. And once again, 4 out of 52 reduces down to 1/13. Okay, so this time it'll be 1/13 times 1/13. So that's going to be 1 out of 169. Okay, move that decimal point 1, 2. Okay, so that's going to be 0.59%. Okay, now what is the probability that you draw a face card given that you have drawn a red card? Alright, for this problem, they're only talking about 1 card. Notice that they didn't say you're drawing 2 cards like they did on the last 2 problems. So I would have felt better if the question had been worded, you're drawing 1 card, to make it super clear. But you're drawing 1 card, and they're just saying, what's the probability that it's going to be a face card given that it is a red card. Okay, that's all they're saying. So, like we often do, we love the given problems because it means we can really zero in on that smaller universe, okay, the universe of being a red card. So we can forget about the black cards in this scenario. Okay, so this is our new universe. It only is a red card universe. So given that we are dealing with red cards only, what's the probability of choosing a face card? So in this universe, there are 6 face cards, as you can see, out of a total of 26 cards. Alright, 13 cards per suit, half the deck. Alright, so it's 6 out of 26, which reduces down to 3 out of 13. So that is the probability. It's 3 out of 13, which is 0.2308. Got to round up. Alright, that's the answer to that one. So that's it for the cards. Now let's move on and do these word problems. We're going to have to use some equations and work backwards. Remember, there are 2 main equations that we are dealing with, and these are they. Okay? This is the AND equation. Okay, the probability of, why can I not say the word probability? Probability. Probability. Alright, the probability of A and B is the product of the 2 probabilities. And then we have a formula for the probability of A or B. And it's the sum of the 2 probabilities minus the overlap. Okay, these other formulas that I didn't highlight are just variations on the 2 formulas that I did highlight. Okay, this is the one we'll do for and of course this is for or. Okay, if there is no overlap, then, you know, if you get rid of that part, then it becomes the other formula. So I try not to think of it as 5 formulas. I think of it as 2 formulas, just sort of written in slightly different ways. But we'll see what we need when we need it. If they say something about something given something, then I'll write it this way. No big deal. That was the wrong button. Number 9. Roswell's cafeteria staff is doing research on what items are purchased with other lunch items. They have found that 45% of students purchase chicken tenders on Tuesday. Alright, I think it works best to record what we learn as we read through the problem, otherwise we forget. So we're talking about chicken tenders. Alright, I'll just say chicken. And they're telling us that, what was that, 45%? 45% of students purchase chicken tenders. Alright, so the chicken situation, they're giving us the probability of the chicken, okay? And I'm going to call that A, alright? This whole chicken situation, I'm going to call that probability A. So probability A, that's 45%. Okay, and then what's going on? 59% of students purchase pizza on Wednesday. Okay, so now we're talking about Pizza Wednesday. So I'm just going to write pizza here, and this will be event B. So that's not an exclamation point, by the way. Probability of event B, they said that's 59%. I could have called it C for chicken and P for pizza. You know, you can do what you want with the letters. Okay, what else did they say? The study showed that 67% of students purchase chicken tenders or pizza on Wednesday. Okay? So, we're talking about now a situation of chicken or pizza. Okay? So, they're giving us the probability of A or B. And they said that that was, what did they say that was? 67%. Okay. Now, armed with these three pieces of information, probability A, probability B, probability of A or B, what are we supposed to find? What percentage of students, okay, and when they say percentage, that's the same thing as probability. Okay, what percentage of students purchase chicken tenders and pizza? Okay, so we're supposed to find this. We're supposed to find chicken and pizza. Okay, so in symbols, we're supposed to find the probability of A and B. Okay, so we're given these three things: probability A, probability B, probability of A or B, and we're supposed to use those to find this fourth thing, the probability of A and B. Sounds pretty complicated, but you know, if we have these formulas that we're looking at, which one of these formulas involves all four of those things, the three that we're given and the one that we're not? And for starters, look between the two formulas that I highlighted for you. Is it going to be the AND formula or the OR formula that involves those four things? It's sort of a hint that I'm saying four, right? Because the OR formula here is the one that involves four things: this, 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 and this. All right, the AND formula only involves three things. So there's a good bet that we're going to be using the OR formula. So let's see if we can make the OR formula work for us. Alright, so here I've copied over the OR formula. Let's fill in everything we have. Okay, so let's see. We have the probability of A is 45%. Okay, so I'm going to put that right here, 45%. Okay, what else do we have? We have the probability of B is 59%. Okay, so that's plus 59%. Okay, and we also have the probability of A or B. That's this right here. Okay, so that is 67%. Okay, the only thing that we don't have is this. Okay, so minus the probability of A and B. And remember, that's the thing that we're looking for, the probability of A and B. Alright, so all we have to do is solve this equation. Well, what's 45% plus 59%? Alright, that's 104%. So far I've got 67% is equal to 104% minus the probability of A and B. Okay, the overlap. So I could subtract from both sides, yes? Minus 104% on both sides. Okay, that's negative 37%. Is equal to the opposite of the probability of A and B. Alright, we don't want either one of these things to be negative because it doesn't really make sense. So we're going to divide both sides by -1. Alright, so this will become just plain old 37% is equal to the probability of A and B. Okay, there it is. 37%. That's how you do it. Last problem. The probability of a person ordering an iced coffee at Starbucks and being a female customer is 0.17. Okay, iced coffee and female. Okay, so let's write this down. That's a lot of F's. Alright, so iced coffee and female. So we are being given the probability of I and F, and we're told that that is 0.17. Okay, what else are they going to give us? The probability of being a female customer given that a person has ordered iced coffee. Okay, I'm going to change colors here. So let's see. So they're saying female given iced coffee. Alright, so the probability that a person is female given that they ordered iced coffee is what now? Alright, given that a person has ordered iced coffee at Starbucks is 0.40. Okay, that's what we have so far. Find the probability that someone orders an iced coffee. Okay, so we're supposed to find the probability of iced coffee. Okay, so we're given two things, these two things. Whoops, I forgot an E on coffee. We're given two things and we're asked to find a third thing. So it's a matter of which one of these formulas we're going to use. Alright, especially are we going to use the AND formula or are we going to use the OR formula? Okay, let's look back at what we have. Alright, well we have an AND right here, iced coffee and female. Alright, we don't have an OR anywhere. Alright, not what we're looking for, not anything that we're given. So so that's one reason to think that we're looking at the AND formula because of this. Alright, OR is not mentioned. Also, there are only three things here. So and the AND formula involves only three things. So it looks like we're dealing with the AND formula. Now, should I use the normal version or am I going to use this version that has the given in it? Obviously I'm going to use the version with the given in it because this problem mentions female given iced coffee, so might as well go with that specific version of the formula. Alright, so that's what we're going to do. So we're using the AND formula, but we're using this version of it right here. Okay, so I'm just going to copy this over and use it. Alright, this time I think I'll change over. So instead of using A's and B's, I'll go ahead and use I's and F's. Okay, just to show that it doesn't have to be A's and B's. So let me rewrite this formula in using these letters. So instead of having the probability of A and B, alright, I'm going to write the probability of I and F. Okay? So instead of writing the probability of A, I'm going to write the probability of I. Okay, times. And instead of writing the probability of B given A, I'm going to write the probability of F given I. Okay, but you can see that it fits the same pattern. So we are given two of these things, and we're supposed to find the third. So let's just put the numbers in. So we're given the probability of I and F. So that would go right here, 0.17. We are not given the probability of I. That's what we're looking for. Alright, the probability of ordering iced coffee. We are given the probability of being female, given that you order iced coffee, is 0.40. Okay, I feel like maybe I should put that in parentheses or something. Okay, so if I want to find the probability of ordering iced coffee, right, P of I, I'm just going to divide. Alright, this is multiplication, so I'm going to divide to get rid of this. So I will simply divide both sides of the equation by the 0.40. Whoa. Okay, in that way the 0.40s will cancel each other out. 0.17 okay, so that's 0.425. And that is what we were being asked to find. So that's the answer. Alright, of course, if you were dying to write that as a percent, nobody could stop you, because that would be 42.5%. Same thing. Alright, and that was the last problem on this test. So that is going to end our probability and set theory adventure for now. I hope these videos have been helpful. Alright, this was part 3, so make sure that you have watched part 1 and part 2. I will see you on the next video on some other completely different topic.